Welcome to the SSLC physics class. For the first chapter of physics, the effects of electric current. The heating effect, we already discussed Joule's law and its applications, and in the mathematical problems related to Joule's law and the factors affecting the heat produced in particularly in case of the resistance and current and the time. So next what we are going to do is that, so we are here discussing the factors, especially the heating effect of electricity and its uses. So just see some electric appliances that is using in your house. Just see you can see that the electric, that is soldering iron is here. So you can see the soldering iron here, and second one is what is that electric heater, and the third one is electric water heater. So what you see in common is there, here in all these equipments the electrical energy is converted to heat energy. So electrical energy is converted to heat energy and making use of that heat for different purposes. So what is the purpose of this soldering iron? So it is for soldering wires, okay, which is used in electronics and also in electrical appliances. Okay, electronic appliances we are using soldering iron there. So when we go for an electronic workshop or electronic shop which is repairing the TV, everything, TV or radio or some other electronic devices, so we easily see, we can see this soldering iron there. Okay, second thing, we can see the electric heater in our house itself. Okay, electric heater is there. And third one, the olden days water heater. That is a picture which is given now. And now the water heater has changed because we are using solar water heater now, that we will discuss in the coming chapters. So my question is that all these equipments, you are seeing that here it is electrical energy is converting to heat energy. And can you notice the one thing which is common for all these three equipments? What is the common thing it is there? The common thing for these three equipments, there is a heating coil, a heating element is there. That particular element is converting the the electrical energy to heat energy. So that name the particular name the particular part of this equipment which converts the electrical energy to heat energy. That is, what is that? That is the heating coil. Okay, the heating coil is common in this all equipments. So my second question is that, have you noticed it? What should be the specialities for this heating coil, this particular component? What should be the specialities? The first one and foremost thing is that our maximum electrical energy has to be converted to heat energy, and this particular heating coil should be capable of producing more heat without loss of electrical energy. So it has to be maintained red hot for a long time. For remaining red hot, what is the other requirement? We know that for making more heat, the material should have high resistivity. So the second thing is that the material should have high resistivity. What should be the third one? So if you go for the third requirement for the material which is to be used as a heating coil, what should be the third one? The third one, definitely the third one will be the material which is using for a heating coil. That material should not be burned, because if we give current or electricity, the material produces heat. If heat is produced, if the materials burned or melted, so there will be no use. So there should be, the material should have high melting point. Okay, can you name the material which we are using as a heating coil? What will the material? The name of the material is nichrome. Nichrome is an alloy Alloy means it is a mixture of metals. So there is a correct definition for alloy is that there should be a mixture of metals, minimum two metals. Okay, the mixture of two metals. And nichrome means nickel, chromium, iron. So nichrome has all these particular requirement what we discussed. So let us see the requirements once again. What are the requirements? Just see, high resistivity is the first requirement, second requirement is high melting point, and third requirement is that ability to remain red hot for a long time. So we are using our heating coil. If the heating coil get oxidizes, what happens? It will be burned. It will be converted to its corresponding oxide. If it converted to corresponding oxide, what will be the use? So we can use the material only one time. So that oxidization, we have to block that oxidization. For blocking that oxidization, we have to use such a material which resists oxidization. So nichrome is one who does not oxidize us for a long time and giving a red hotness. So that is the advantage of nichrome. So this is a must question in your exams. What are the requirement for a good heating coil? Or nichrome is used as a heating coil. Why? Because nichrome has high resistivity, and nichrome has high melting point, and nichrome has the ability to remain red hot without oxidation. These are the speciality of nichrome. Okay. Now we have discussed about a heating coil and we have discussed about nichrome. We are using nichrome as a heating coil. Then next, you just see, I am showing here some equipments which are very familiar to you. We are using in our house. That is, first one is microwave oven, and second one is the modern equipment which we use in our house. Even we are substituting our gas LPG stoves with our induction cooker. So two equipments which are showing here. The first one is microwave oven, and second one is our induction cooker. So what is the speciality of these two equipments? Can you find any heating coil here in these equipments? So there are such equipments, such electrical equipments without heating coils. So example for electrical heating equipments, we use it for cooking. So that is our microwave oven, and second one is which is our induction cooker. So now we come to the practical application, another practical application of the heating effect of current. The picture showing here is very familiar to you because we see these equipments in your house. Okay, what is this picture? So what is this one? This is called a safety fuse. Okay, what is the use of safety fuse? Why it is called a safety fuse? So we know that in our house the current or the electricity is coming from electricity board through the post or the electric line. Okay, actually in our house there are a lot of electric equipments are there. Our TV, fridge, washing machine, fan, mixer, everything is there. So each and every equipment need a particular current. Okay, amperage of current is needed. So if the current is excess, what happens? If the current in the circuit is excess, what happens? Definitely that will be harmful to our electrical equipments. So we have to block the excess current that may come to the circuit. So there we are using a device which is called a safety fuse. Safety fuse always protects your equipments out of the excess current coming from external circuit, from KCB or somewhere else. Okay, so this safety fuse always protects your equipments from excess current coming to the circuit. How it protects? The safety fuse sacrifices themselves. Why? Safety fuse is a thin wire. Safety fuse is a thin wire. When excess current passes through the safety fuse, due to the heating effect of current, it melts itself. Thereby, it protects the equipment. That's why the fuse is called a safety fuse. Usually, an alloy of tin and lead. Alloy of tin and lead is used as a safety fuse. A thin wire of the alloy of tin and lead is used as a safety fuse. Okay, it is having low melting point, comparatively low melting point, because when excess current comes, the fuse wire gets heated, and because of the small heat generated there, the fuse wire get fused or it melted. Okay, then actually we have some question in our textbook. Okay, which are the circumstances that causes high electric current leading to melting the fuse wire? So that is very important thing. So which are the two conditions where the high current comes in the circuit? So there you should remember two names. The first one is short circuit and second thing is overloading. The two words you should remember, which are the two situations where excess current comes to the circuit. The first one is short circuit, second is overloading. So what is short circuit? Short circuit is very simple. We know that the electricity comes into our house in two lines. One is phase line, another one is neutral lines. So phase line is indicated in red color and neutral is indicated in black color. Okay, and phase line and neutral line, if it touches themselves without a resistor. So what is a resistor? A bulb or a fan or a TV or a fridge or something. Some equipments we have. That equipment is a resistor. So without a resistor, if the two lines touches themselves, so suddenly excess current goes through the circuit. Excess current goes through the circuit. So that is called short circuit. The short circuit is simply the touching of phase line and neutral line together without having a resistor or an equipment in between them. Okay, so while the short circuit, excess current passes through the circuit. So to avoid damage of our other electrical equipments, what happens while the time of short circuit, the fuse wire get melts. And second thing is that overloading. What is overloading? It is very simple. You can see a picture here for overloading. What is overloading? Overloading, we know that we have a 3-pin plug or a socket, 3-pin socket. Okay, so in 3-pin sockets, there are a lot of 2-pin sockets are there. So we take current for our mobile charger, and we take current for another light. We get current for our iron box. We get current for connection for our TV or everything. It is from a single plug, single socket. What happens? From the single point, excess current drawn. So when you draw excess current from a single point, the amount of current passing through the single point increases. So what happens? Because of that, the excess current comes through the circuit and it gets overloaded. So when it overloading, fuse wire also melts. So what are the situations where the safety fuse get melts? There are two situations, short circuit and overloading. Okay, then we will come to another point. So in our house, the safety fuse get melted. Okay, because of some short circuit or something like that, or overloading or something. We have to include another fuse wire in the fuse carrier. Okay, in fuse carrier there are two things. One is the fuse carrier, another one is its base. So we are taking out the fuse carrier from the base. Okay, two screws are there and two metal pieces are there, and we have to tie the fuse wire in the fuse carrier. Okay, so while while including fuse wire in the fuse carrier, what are the important points to remember? So when you include fuse wire in the fuse carrier, the important points to remember is that the first and foremost thing, you should use a thin metal wire. Normally, we use a thin copper wire. There is a use of tin and lead is used for our fuse wire, but normally we will not get the alloy of tin and lead, but we use the copper wire which is available in our house. A thin single wire has to be used. Why? If you use a thick wire, even if high current passes through the fuse wire, it will not melt. Why? Because of its thickness. Okay, because of its thickness, it allows high current. It will not melt. So the first and foremost thing, always use a thin wire. Okay, the ends of the fuse wire must be connected firmly in appropriate points. The ends of the two wires must be connected firmly, that is tightly with the screws. Okay, otherwise what happens, there will be a leakage of current, and after all, there also in leakage is current, that spark will be there, and there will be a chance for getting the fuse wire get fused. The third and most important thing is that the fuse wire should not project out of the carrier base. The fuse wire should not project out of the carrier base. If there is a carrier base, the fuse wire should not project from it. If the fuse wire is projected from the carrier base, what happens? So we know that the fuse is connecting in phase line. That is series to the phase line. It is series to the phase line. We are connecting in phase line. So if the ends of the fuse wire ejected or projected from the fuse carrier, if there is a chance for getting in touch with it, definitely fatal. Definitely it will be fatal. Okay, these are the general things for fuse wire. Okay, today we have discussed important things about what are the heating effect of electric current. The heating effect of electric current, and heating effect, we first seen the heating coil. The instrument, the equipment is used for heating coil, and what are the material we use for heating coil? It is nichrome. Why nichrome is used for heating coil? Because of the property of high resistivity, high melting point, and ability to remain red hot for long time without oxidation. These are the three important things. And again we come to another thing, the equipments which do not have heating coils. So that is, we discussed about our microwave oven. Two things, microwave oven, and second thing is induction cooker. Then we come to fuse wire, safety fuse, and safety fuse is used in our household wiring because for safety of our electric equipments. So fuse wire itself melts. So a alloy of tin and lead is used for making fuse wires. Okay, so fuse wire, there are two chances for melting the fuse wire. That is, one is short circuit and second thing is overloading. And another thing what we discussed is that while including fuse wire in the fuse carrier, three things you have to remember. The first one is a thin wire has to be taken as a fuse wire. Second thing, there is two screws are there. The fuse wire should firmly fit screwed into the two particular points. Okay, and the third one what we have discussed is that the third very important thing, should not allow the fuse wire to eject outside to the fuse carrier, because it is a life-threatening situations, fatal for electric shock. Okay, to avoid electric shock, you should not allow the fuse wire to eject from the fuse carrier. These are the important things what we have discussed. Okay, this is an exclusive class for English medium students. I think you understood the things what we discussed today. In the coming classes, we will discuss the rest of the chapter in the same manner, and I will send you the questions, so definitely you can answer the questions and you will get the notes accordingly. Okay, thank you for your patient hearing. Thank you.